Hello everyone, welcome to my channel. In this video I have this integral to look at. It's the integral of dx all over the square root of 3 plus 2x minus x squared. The approach, as you would suggest or guess, we are going to use trig substitution as follows. So we have the integral of dx all over the square root of 3 plus 2x minus x squared. Right, we have to perform manipulation of the expression under the square root sign as follows. So I want to rewrite it. Step number 1, we're going to say this is the same as dx all over the square root of, watch how I'm going to change this expression here, to 3 minus, open brackets, x squared minus 2x. There you have it. If you remove these brackets, you're getting back to that expression there. Now, I want you to look at this expression here, x squared minus 2x. I want to complete the square of that as follows. So, if I want to complete the square of this expression, I'm going to say let x squared minus 2x plus some constant k, this should be equal to the square root of x squared is x, and then plus some number a, which we have to determine o squared. Now I'm have to expand the right hand side. You'll agree with me that the left hand side remains the same. X squared minus 2x plus k is equal to the right hand side. If you expand it, you're going to get x squared plus 2ax plus a squared. Now equating coefficients, you can see the x squared is taken care of, but the coefficient of x on the left should be equal to the coefficient of x on the right. And the constant term on the left should be equal to the constant term on the right. So therefore we are saying 2a, the answer must be equal to minus 2. 2a is equal to minus 2. Solving for a here, you get a equals minus 1. And then on the other side, we are going to have k squared. K is equal to a squared. Now, bringing minus 1 this side, you'll agree with me that k must be equal to minus 1 all squared, and the answer is 1. So what it means is that if we take 1, we put it here, we must take minus 1, put it there. So we are saying, therefore, x squared minus 2x plus some constant k, where k equals 1. So we put 1 there. This must be equal to x. What is the value of a? Minus 1. And we square that. Fantastic. Now, this expression under the square sign will be changed as follows. Moving on to our next page. And I want to make sure that you can see this very clearly. Right. So now I'm saying, therefore, our integral now changes to dx all over the square root of, watch this, 3 minus, open brackets, I'm going to have x squared minus 2x plus 1. But now I don't have to change this integral here. I do not want to change this integral. And therefore, when I add 1, I must subtract 1 there. So we're going to say minus 1. Write that like that. Now, this is brilliant because then we can rewrite this part here to, remember, x minus 1 all squared. So now we're saying this is the same as the integral of dx all over the square root of, we have 3 minus, watch this, x minus 1 all squared minus 1. That's what we have under the square root sign, because this one here, completing the square, gave us x minus 1 all squared. Now, we have to remove these brackets. So now we're saying this is the same as the integral of dx all over the square root of 3 minus x minus 1 all squared, we have to say plus 1. Because if you remove these brackets, that minus 1 becomes plus 1. And these can be put together. So this is the same as same as the integral of dx all over square root of 3 plus 1 minus x minus 1 all squared. And this, if you agree with me, is the same as the integral of dx all over the square root of 4 minus x minus 1 all squared. Fantastic. Now, if you would recall this, I want to remind you of something here. I want to remind you of this one here. Sine square root of x plus cos square root of x, the answer is always 1. Very special trig identity. Solving for sine squared x, making sine squared x subject to formula, you'll agree with me that, and in this case, I want to make cosine x subject to formula. So cosine squared of x is equal to 1 minus sine squared x. Now, looking at this part here, we can produce it down here. We have to just make sure that there's a 1 here so that it complies with this. Then whatever will be in that place, we're going to let it be equal to sine x, and then we can sine theta, we can carry on from there. Taking us to the next page, watch what I'm going to do now, how I transform this expression down there. I'll transform it as follows. I'm going to force 4 to be the common factor there as follows. So we're going to say this is the same as the integral of dx all over down there square root of, we're going to force 4 to be the common factor. 4 open brackets. 4 into 4, the answer is 1. 4 into that expression, we're going to say x minus 1 all squared all over 4, like that. Fantastic. Now, remember the product of two numbers, we can take 4 as a number on its own, and we take square root of 4, it will be 2. So we're saying this is the same as the integral of dx all over square root of 4 times square root of, this will be 1 minus, watch how I'm going to rewrite this expression here, x minus 1 all over 2, and I square the whole expression, like so. Fantastic. If you remove these two brackets, you're back there. Right, so now what I'm going to do is to take, remember square root of 4 is 2, I'm going to take it out and it's dividing. So we have 1 over 2 times the integral of dx all over, this expression here is going to be square root of 1 minus x minus 1 all over 2, and we're saying all squared. Fantastic. Now, at this point, I'm going to let, like I said, trig substitution, I'm going to let sine theta be equal to x minus 1 all over 2. So let sine of theta be equal to x minus 1 all over 2, so that I can produce 1 minus sine squared in that place. Right, so now I'm going to have to multiply both sides by 2. So this is the same as, maybe before I do that, I'm going to have to solve for theta first. So this is going to be arc sine or sine inverse of x minus 1 all over 2. One equation. The second equation we're going to obtain is multiply by 2 both sides. We get 2 sine theta is equal to x minus 1. At this point, I'm going to have to differentiate both sides with respect to x. Now notice on the left hand side we have to use chain rule there because we have sine theta. So we differentiate sine first and then differentiate theta. So now I'm going to say derivative with respect to x of 2 sine theta. The answer must be equal to derivative with respect to x of x minus 1. On the left, 2 is a constant, take it out, and derivative of sine is cosine, and then we have to say d theta dx. Chain rule there is equal to derivative of x with respect to x is 1, derivative of minus 1 with respect to x is 0 because minus 1 is a constant. Now multiply by dx both sides, you're going to get 2 cos of theta d theta is equal to dx. Fantastic. Now this one here, if you agree with me, is what you have in the numerator there. And in that place, I'm going to have sine squared theta. And then I have 1 over 2 outside. So we're saying, therefore, what we're saying is that integral changes to 1 over 2, like I said, times the integral of 2 cosine of theta d theta all over the square root of 1 minus sine squared of theta. Notice how this is transformed. Dx must be replaced by that. In that place, we put sine theta, but it has to be squared because we have a square here. And so it transforms into that. But now, remember from here, we said this expression here is just that expression. So I'm going to have cos squared there in place of, the whole of this expression simplifies to cosine cos squared of x. So we are saying this is the same as 1 over 2 times the integral of 2 cosine of theta d theta all over square root of cos squared of theta. Fantastic. Now you agree with me here that this cancels that. And if you allow me to take this to page 5 and just complete it, we're going to have now, this is on page 5. Now what we have is the following. So that integral now transforms as follows. I'm going to say that is equal to 1 over 2 times 2, take the 2 out, cos a constant times the integral of cos of theta d theta all over cos theta. And obviously these cancel. We have 1 there. And what do we have outside? We just have 1. And so we have 1 d theta there, integral of 1 d theta. You agree with me that the answer is theta. I explained how that is done in one of my videos. You may wish to go back and check on techniques of integration. So this is what we have. Now taking us to page 1, just to check the relationship between theta and our x, which is the original variable that we have. We have the following. It's actually on page 2 because page 1 was manipulation. Even on page 2, still manipulation. Page 3 is where we find it, I think. Page 4, no, on page 3. Here it is. The relationship between theta and x is this one here. So I'm going to have to say sine inverse of x minus 1 over 2 in that place. But remember to say plus c because this is an indefinite integral. So our final solution then is sine inverse or x sine of x minus 1 all over 2, and then we have to say plus c as the constant of integration. All right, just to remind you where we're coming from, this is the integral we've been looking at, and our final solution is that one. Tell me what you think about this integral. I hope you found that useful. I'll see you in the next one.